This video is all about arrays. We will review some concepts about one-dimensional arrays and expand into multi-dimensional arrays. An array is a collection of like elements. There are many engineering applications, some of which we're going to look at, that use arrays. And MATLAB stores all of its data in arrays, and it performs all numerical computations using array operations. So we need to understand arrays and array operations in order to be able to use MATLAB effectively as a computing tool. We already know a one-dimensional array is also called a vector, and it can be either a row of numbers or a column of numbers. A two-dimensional array is also referred to as a matrix. And when you think about matrix, you should just think about a table of numbers. It has multiple rows, multiple columns. And the size of the matrix is the number of rows by the number of columns. So here we have a couple of matrices. You can see that matrix A has 2 rows and 3 columns. So this is a 2 by 3 matrix. And matrix B has 3 rows and 4 columns. So it's a 3 by 4 matrix. If I refer to matrix A, that's all the values in matrix A. But if I look at A2, 3, that means the element that's sitting in row 2 and column 3 of matrix A, and in this case that would be a value of 10. If I refer to B1, 4, that means I want to look at the element that's sitting in row 1 and column 4 of the B matrix, and that would be the value of 82. We can have multi-dimensional arrays, and a good example of a three-dimensional array would be a color image, like a digital picture that you would take with your camera. So the rows and the columns would represent all of the various pixels in that image, and the third dimension would represent the intensity of red, the intensity of green, and the intensity of blue in each of those pixels. So we're going to talk about creating and manipulating arrays in MATLAB, and you've already had some experience with this. You have created one-dimensional arrays or vectors when you've done plotting. So this part should look real familiar. One way that I can create an array is simply by naming my vector. In this case, I'm going to call it A, equals square brackets, start typing in numbers. And if I do that, of course, I'm going to get a row with 4 elements in it. If I define a vector and instead of just spacing between the numbers, I terminate each number with a semicolon, that semicolon means start a new row. So in this case, my vector B is going to be a column of numbers rather than a row of values. Now what if I want to have a matrix? Well, I can use exactly the same idea. In this case, I'm going to create a matrix called C. So I type all the values that I want to go in the first row of that matrix. I terminate that row using a semicolon, and then I type all the values that I would like to go in the second row. And if I had a third row for this matrix, I would terminate row 2 with a semicolon and type the values that I wanted to go into row 3. In this case, I only have 2 rows. Now, what about this command? I get an error if I type this command, and if you look at the command, you'll see why. Because I'm trying to enter 3 values into row 1, 1.3, 7.2, and 9.5, but I'm trying to put 4 values into row 2. Can't do this. All of your rows have to have exactly the same number of values. Now, there's lots of other ways that you can create arrays besides manually typing numbers in. You already know we can pull in data from an Excel file and pull that in as an array. This first function, start, increment, maximum, you've used that multiple times to create a vector of values for the x-axis when you're plotting. You've also used the command linspace before. Linspace, start, end, number of points. Couple that you haven't seen before, I, n, n, creates an identity matrix. If you don't know what an identity matrix is, we are going to talk about that in a later video, but it's basically a matrix that has 1s down the diagonal and 0s everywhere else. Zeros, n, m, creates a n by m matrix of all zeros, and 1's n comma m creates an n by m matrix that's all filled with 1's. I also have some random functions that will randomly create a matrix of whatever size I want with various values filled in. So RANDI stands for random integer, and I can create a matrix of random integers going from imin to imax, and it's an n by m matrix. And we're actually going to do this a little bit later on. There's another function called randn, and that will create a matrix of random numbers that are normally distributed with a mean of 0 and a standard deviation of 1. And if you're not familiar with the term normally distributed, I bet you are familiar with a bell curve. You've seen a bell curve before. IQ is distributed along a bell curve. SAT scores are distributed along a bell curve. Same thing here with RANDN. It is centered at 0 with a standard deviation of 1. RAND creates an n by m matrix of random numbers that are uniformly distributed on the interval from 0 to 1. This means any number from 0 to 1 is equally likely to appear in this matrix. And RANDPERM picks unique integers to go into the matrix. So now let's review indexing vectors. Suppose we create this vector x that has these values. X has 8 values in it. If I refer to x, I'm referring to all 8 of the values in the vector x. If I want to go in and yank out one particular value out of this vector x, I have to index into the vector x. In MATLAB, array indexing starts with 1. So if I do x parentheses 1, that's referring to the first element in the vector, which in this case would be -5. If I do x and in parentheses 2, that refers specifically to the second value in that vector x, which in this case is 2. I could yank out sets of values. So if I do x 3:7, that's going to produce a vector that contains entries 3 through 7 of my original vector x. If I want to find out how many entries are in a vector x, I can use the length command. Length of x will produce exactly how many entries are entered into that vector x. So let's take a look at an example. Same vector we just took a look at. Couple of MATLAB commands. If I type at the MATLAB command prompt x of 3, it's going to pull out the third entry in matrix x, which is 1. So I get x of 3, answer equals 1. If I type x 2:6, this is going to pull out the second entry through the sixth entry, and I'm going to get those entries in a vector. So if I type x 2:6, I'm going to see a vector come back that has entries 2 through 6 in it. I can do weird stuff too. I mean, if I type x 1:2:8, you've seen this before. You know what that means. That means start at 1, increment by 2, end at a number that's no larger than 8. So if we count our way through this, this would be entry 1, entry 3, entry 5, and entry 7. Now why you would want to pull every other entry like that out, I don't know, but you can do it if you want to. And finally, I don't even need a pattern. I can go in and I can say, hey, I want the first entry in x, the sixth entry in x, and the 8th entry in x, and I can pull those out also. Now, if I want to index into a matrix, that's a little bit different because a matrix is two-dimensional. So instead of just specifying an entry number, I actually have to specify which row the element is in that I'm trying to get and which column that element is in. So let's assume that we have a matrix A and it has at least 4 rows and 7 columns. If I type A 3:5, that means that I am pointing to the value in the matrix A that is sitting in row 3, column 5. If I do A3, colon, the 3, clearly that's the first entry, so it's talking about row 3. The colon is actually a shortcut that says take row 3 and all of the columns in row number 3. Now I could be more specific about that, but that's a nice little shortcut for grabbing out the entire row 3 sitting in matrix A. I can reverse that, and if I do A colon comma 2, that means that I want to pull out column 2, and I want to pull out all of the rows that are sitting in column 2. And again, I can pull sections of this matrix out. So if I did this A 2 colon 4, 3 colon 5, that would pull out everything that in A that was in rows 2 through 4 and in columns 3 through 5. If you want to know how many elements, how many rows and columns a matrix has, you can use the size command. So if I type rows columns equals size of A, rows is going to come back as the number of rows in my matrix A, and the variable COLS will come back as the number of columns in matrix A. So let's do an example, and you can see here that I wasn't patient enough to type all the entries in a matrix. I just went ahead and used the random integer command. So this random integer command, RANDI, the first vector there, 0 to 10, says that I want integers that only range from 0 up to 10. And then the second vector, 4 comma 5, says how big I want my matrix to be. And in this case, I want my matrix to have 4 rows and 5 columns. And you can see, sure enough, I get a matrix. All the numbers in that matrix are from 0 up to 10, and it is a 4 by 5 matrix. If I type that command in MATLAB 3 or 4 times, I'm going to keep getting a different matrix every time because it's a random generation of these values. So if I type at the MATLAB command prompt matrix 2 comma 3, that should go to row 2, column 3 of the matrix, and what I have sitting in row 2 and column 3 is 10. So it comes back with 10. If I type matrix colon comma 4, that means all rows and column 4. And if I look at column 4, my column 4 is 2825. And sure enough, that's what I get back as a column vector. If I do matrix 3 comma 2 colon 4, that means go to row 3 and pull out everything from columns 2 to column 4. Well, if I go to row 3 and I go to column 2, 3, and 4, I have the values 1, 3, 2. And that's what I get. If I do matrix 2 colon 3, 3 colon 5, that means to go to rows 2 and 3, pull out everything that is sitting in columns 3 through 5. So that's actually going to pull out a section of values, and I'm going to get a 2 by 3 matrix. So that's how you index into a matrix. If I refer to matrix itself, that's all the values. That's all 20 values sitting in that. If I want to refer to a section of that matrix, or I want to grab out a specific value of the matrix, I have to use this idea of indexing. What row or rows is it in? What column or columns is my information in? And these functions we already talked about, size of A and length of A, you're going to find those to be extraordinarily useful functions. Size of A will tell you how many rows and how many columns a matrix has. Length, you're only going to want to use this for vectors. It will tell you how many entries there are in a vector. It's not particularly useful for matrices because it gives you the largest dimension, but that doesn't tell you whether it's giving you back rows or columns. So for matrices, always use size. So now we're going to review the concept of looping through a one-dimensional array or a vector. And if I want to go through every value of an array and possibly do something with those values, I have to do a loop. And with a one-dimensional array, I just need a single for loop. Alright, so let's look at the following code and see if we can figure out what's going to happen here. I have a very simple vector x. It only has 5 entries. My for loop says for k equal 1 to the length of x. X has 5 entries, so that's literally the same as saying for k equal 1 to 5. After that, I have a conditional statement. So let's see what happens. So we're going to walk through this. When k is equal to 1, right, for k equal to 1, if x of 1 is less than 0. Is x of 1 less than 0? Well, yeah, x of 1 is negative 1, so that is less than 0. The condition is true, so I overwrite x of 1, and I put a 0 in that spot. So now the minus 1 in entry 1 has been replaced by a 0. I loop around again. Now k is 2. Now I'm looking at x of 2. Is x of 2 less than 0? No, x of 2 is 3. So what happens? Skips the conditional, skips to the end, goes back around the loop. So entry 2 stays the same. Third time around. Now I'm looking at x of 3. Is x of 3 less than 0? Nope, it's 5, so nothing happens. Fourth time around. Is x of 4 less than 0? Yeah, it is. It's minus 7. So again, I'm going to overwrite the fourth entry in x with a 0. Finally, fifth time around, x of 5 is 53. That's certainly not less than 0, so nothing happens to the fifth entry of x. I am now done with the loop. I've looped completely through the vector x, and so now I hit those display statements, and you can see that what's happened in this simple piece of code is all the negative entries in x have been replaced by zeros. Alright, so now it's your turn.